Hi, welcome to the Calculus 3 assignment practice series. And we are in the unit vectors and the geometry of space. This is going to be the last assignment practice for this unit. So in this video, we're going to take a look at some of the problems related to the cylinders and the quadratic surfaces here. Okay, so basically we learn how to recognize the surface and the formulas, and then we can do some easy graphs there. Okay, so now let's go to our worksheets and take a look here. So where is my, oh, here we go. All right, so here, all right, so the first one's here. Okay, so let's take a look. They say let's try to do problem number 1 here. And so problem number 1, the first problem they asked you said, what does the equation y equal to x squared represent in R2? Oh, this is easy. We know this is our quadratic formula, right? So the quadratic give you what? Give you a parabola, right? Okay, and then also they said, what does it represent in R3 here? So in R3, I have y equal to the x squared, correct? I have y equal to the x squared, and I am missing a variable. So we know if I'm missing a variable, will become a what? Will become a cylinder, right? So this will be a parabolical cylinder. So we're going to be a parabolic cylinders here. And so the same things here, the z equal to the y square is also going to have a parabolical cylinders here, right? And it's just rotate, just have a different orientations here. So let's take a look. How do I scratch, right? So let's take a look at the B's here. For the y equal to the x squared here, right? So let's take a look at how do I scratch it, by using the trace here. Okay, so in general, it's not too easy to scratch, but I think, okay, so here. Okay, so this is my x-axis, this is my y-axis, and this is my z-axis. Let's say here, okay, no, this one's here. This is my x-axis. This is my y-axis here. All right. Okay, so now this is my axis, this is my y-axis here. Okay, so the first one here, when we talk about the traces, right? So we do just focus on the y equal to the x squared, right? So the y equal to the x squared. So I know when you do it, you will get, if you do it in the x-axis and the y-axis, what do you have here? You're going to have a parabola, right? So you're going to have a parabola in the y and the x-axis here. And so this is a parabola, but then since I don't have z, so I know my graph is going to be parallel to what? My graph going to be parallel to z-axis here, right? So this one's here are going to do like this. And then the top here going to like here, and then here, this is going to here. Okay, so let's see. You can see what I graph here, right? So here, it's sometimes not easy to visualize that in the R3s here. So this is here, and then I go here. Okay, and so here. So can you kind of see here? So this one go extended to that, right? So it's kind of like it's a parabola. It's kind of like you bend it over, right? The xy, and then you parallel to the, so this is the cylinders, right? So it's kind of like the parallel to the z-axis here. Okay, so the same way is here, you know, let's take a look at the y equal to ex squared. So they said, what is the y equal to the e to the x? All right, so this is exponentials, right? So if in R2, this is how do we graph it? This is x and the y. Then the y equal to the e-axis will be something like that, correct? All right, so now let's use this trace. Let's see, we'll be able to graph it in the R3s here. Okay, so let's try again. So like I say, it's typical, try to do R3. It's not too simple a question, the way to do that. Okay, so here, okay. So I would say this is my x-axis, this is my x-axis here, this is my y-axis, this is my z-axis, right? Okay, so this is the, you know, so this is the x, y, so in here, okay, so like in here, this is my positives, right? So this is positive, this is negative. Okay, so the first trace is here. Okay, so it will be, if you do the x, y, so when the x approach to negative infinity, so you're going to have a sum of like this, correct? And touch the 1, then the y is going to go what? Go up, right? That's what is the, you know, this trace means here. So now because of this trace, because this one going to touch it once, right? So now that's why I know the graph here going to be another cylinder will parallel to the z-axis here, all right? So now let's see we can do that. So this will be like this. And so here, parallel, so go like this. Okay, so here. Okay, so this one's here, then I have another one, I can go like this. All right, so this one is not too bad, right? So I think this one is not too bad. See here, right? So it's kind of like it's an exponential function, and now because you're missing the z, so that's why you're parallel to the z-axis here. And okay, so for the next few problems, basically you said identify the surface. Basically what you're doing here is just you compare to the 6 formulas we have, right? Okay, so now I want to do a couple of problems here. So the first problems here, they want to do like the mix and match is here, right? So for here, I want to take a look here, right? So I have two, you know, ellipsoid, right? I have two ellipsoid, and I know the ellipsoid, the formula will be what? Will be like a square plus square plus square, something like that. So I have two things here, right? So both of these two, right? So it's kind of satisfy the ellipsoid equations here. So, but which one is which here? Okay, so which one is which? So let's take a look which one is which here. Okay, so let's take a look at these ones here. For the number 21s here, right? So this is x squared plus 4y squared plus 9z squared equal to 1. So if I want to change to this ellipsoid here, x squared, a squared, b squared, c squares, right? So what I need to do is here, so I can rechange these ones here. This is x squared plus, this is y squared. So 4, I can change it to 1/2 of the y squared. And the plus, this is z squared. So this is what? 1/3 square equal to 1, right? So this is number 21. So number 22, I can do the same things here, right? So number 22 see here, I can change this is 9x squared plus 4y squared plus z squared equal to 1. So I can change this is x squared over what? 1/3 square plus y squared to the 1/2 square plus z square, of course, is equal over 1s, right? So this is over 1. Okay, so from the ellipsoid, we know that those are the kind of like the radius, right? So this kind of like the radius to the your x-axis, right? So x-axis or y-axis or z-axis. So this one's here. So this is x. This is the 1/2. This is 1/3. That means the ellipsoid, the x-axis has to be the longest one, and y is the next one, z is 1/3. So let's take a look which one it will be. Okay, so let's say the y has to be the longest one when they touch the x-axis. Obviously, this is not, z is longer than that. So here, I'll see here, right? So this is the one, right? So because the x is the longest axis is this much, is 1 here, right? Then the y, so if you take a look at the y's here, right? So the y is 1/2. So the y have to be a little bit tall, bigger than the z. So this is 1/2, right? So this is kind of like, this is 1/2. And then for the z is what? Z is here, this is what? Is 1/3, right? So 1/2 has to be a little bit bigger than 1/3. So I know for 21 is what? So for the 21, which one? It match here, it match the number 7 here. All right, so match the number 7. So the same ways here, you take a look at these ones here, right? So these ones here, the way, if you take a look here, the longest one has to be on the z, then the y, then x here. So it's ellipsoid, but the z has to be the longest one. That's why this will be the ellipsoid. It's kind of extend up. So the z has to be the longest one. And then what happened to the y? Y is here, right? So y is 1/2, right? So this is 1/2. And then what is the x here? The x is here, right? So x is 1/3. It has to be a little bit longer than that. So that's why the number 22, I'm going to match the what? The 4s here. Okay, so all the others are pretty, I think, straightforward. You just need to recognize. So here are all the summary about the different formula. So you just need to recognize the form, and then you know how you identify, which axis they are parallel to, right? So that's why you might have the different, the orientations here. Okay, so that's it. So this one is a very easy homework assignment. Basically, you look at the graph and you identify it, okay? And then the sketch, try to kind of graph in the sketch part is a little hard, but, basically you just do the sketch on the trace. The trace, that means you let the third variable, become the different number, and then you trace it to see what it looks like. Okay, so first things you will do is try to match, right? So match the formula to see, hey, what is this one match, right? So you say, okay, this one's here is elliptic paraboloid or is a cone, and then you kind of be careful about where is the axis, they parallel to. All right, that's it. And so let's finish all this unit. So this one is an easy video, it's an easy assignment. So basically just want to get familiar with the, what type of the, in the R3, what are the cylinders looks like, or what is the quadratic surface looks like. All right, that's it. And we're going to talk to you. And in the next video, we're going to start a new unit. We're going to talk about how to take the derivative, in the higher dimension space here. Okay, that's it. Okay, bye. You have a good day. And hope you kind of enjoy those graphs here. Okay, talk to you later. Okay, bye-bye.